It's now time to shift away from millennials, and I doubt there'll be any more emojis or Instagram mentions in the next presentation from Yanir Farber, who's also from the Hebrew University of Jerusalem, who's going to talk about quantum computing. So really a look into the future. Thank you.
Good morning, everybody, and thank you, Hugo, for having me. We're going to discuss in the next 10 minutes about quantum technology. And it's not as frightening as you might think. We try to do it very friendly, and it is. Basically, quantum technology uses properties of quantum mechanics, such as interaction between molecules, atoms, photons, to create quantum-based devices and systems. Again, it was bombastic, but you can think of very accurate clocks, which are produced that way, about medical imaging systems, about quantum computers. And we are right now in the second quantum technology revolution. The first one started in the 40s and the 50s. It produced things like transistor and laser, which are the base for computers and for the internet of today. And now the second one has three segments. One of them is quantum sensing, again, medical imaging. We were discussing earlier cars, and you need a lot of sensing for cars. Quantum technology is involved there as well. We'll talk about quantum communication. QuantLR is a company that aims to provide quantum communication or quantum encryption solution. Quantum encryption solutions, are the only proven, ultimately secured solution to secure communication lines. You cannot hack a communication line once it's secured with quantum communication, and we'll discuss it later. And obviously, quantum computers. There is a big buzz around quantum computers. I'm sure you all heard about it, and we'll discuss it in the next 2 minutes. So quantum computers, the advantage of quantum computers are that they simply can process tasks in parallel, simultaneously. So there are a lot of questions that are being asked, and all of those are processed simultaneously, in parallel, producing many answers simultaneously. Instead, unlike a regular computer, which does it one by one, just every task, once it completes one of them, it starts the new one. So quantum computer will be able to process things that a regular computer can process in 20 years. It will be able to do it in 10 minutes, 5 minutes, depending on its strength. Now, quantum computers are really a vision of academy up to a few years. It was really something that scientists were playing with, and until in the last three years, these type of companies went into the game. Companies like Intel, IBM, Google, and you can see qubits is the way that they measure strength of quantum computers. The amount of qubits increased dramatically. And now it is not only companies that are involved, but countries. You see the US, China, Germany, the UK just announced that they're going to invest $1 billion in quantum technology. So countries are involved in producing and developing quantum computers. Now, quantum computers are a threat as well, and I will show it in a few minutes. But let's discuss encryption. All cyber industry is based on encrypting messages. When you are transferring information from point to point, it is encrypted. You don't want anyone to tap it and to hack it. All encryption methods today are based on complicated math problems. These type of math problems it is possible to solve them, but it might take you 20 years, because if you're factoring, you need to factor 2 prime numbers, which are extremely big. Computers that exist today, it might take them, I don't know, 20, 30, 50, 100 years to solve these type of problems. So all these type of encryption is based on what is called computational complexity. On one hand, computers are becoming stronger every 18 months because of CPU power, because of error correction algorithm. And once computers are getting stronger, the algorithms are getting weaker, obviously. But the big thing that is the monster around the corner is quantum computers. Quantum computers, again, they view the advantages. They will be everywhere. There are many optimization problems that we will be able to solve them quite easily in the future. but quantum computers will be able to break all the encryption that exists today. Actually, in 1994, a scientist by the name of Peter Shaw from Bell Laboratories showed that quantum computer will be able to efficiently and effectively crack the RSA, which is the most common encryption method today. And actually, it was the first thing that was proven for quantum algorithm. The first thing that the quantum algorithm specialist was trying to do was to crack the RSA, and it was proven that quantum computer, once it will be strong enough, it will be able to crack it quite efficiently. So, as I mentioned, the current encryption is based on math, and this is, can be decrypted. And what we are doing, quantum encryption, is based on physics. And it is proven, there is a scientific proof, that it's impossible to break a code that was created using quantum encryption. And basically, the advantage is, again, it is impossible to break it. Once somebody is tapping the line, somebody is staying on the line trying to hack, trying to tap, both sides knows it immediately. Just think that today, when somebody is stealing your credit card, the problem is not the fact that your credit card number, the problem is not that the credit card number was stolen, is that you don't know about it. If you would know about it in 10 seconds, 1 minute, no harm done. But the problem is that you know about it only when money is being stolen or once somebody is trying to threat you or something like that. With quantum encryption, it is impossible to hack. And if somebody is trying to do so, both sides immediately knows that somebody is on the line. Nevertheless, you can still continue use this very line to communicate. The hacker will get nothing. This is part of the algorithms which are involved there. And you will be able to continue and communicate smoothly. Now we are basically, quantum encryption was started in 1984. And there is a company right now from Switzerland which are producing quantum encryption solutions. We are not the first one to introduce it, but we would like to do it 10 times cheaper. We would like to integrate it with equipment, communication hardware equipment which exists today. And this is our unique selling proposition. Now, the customers that are looking into it, the first ones are 5G operators, because as you heard today, the internet, all the 5G operators, these type of things will activate cars, will activate IoT. It is going to perform much more sensitive tasks than the current internet. And all these type of companies are looking for secure solutions. And quantum encryption is ultimate secure solution. So you can deploy it, and then you will not have to change it, not today, not in the future, because until laws of physics will be changed. Other segments that are looking in this type of solutions are obviously defense, government, finance. You're really transmitting extremely sensitive information to your bank and back from your bank. Medical information, based on the EU legislation, medical records have to be kept secret for 40 years. So if you're not going to protect them today, then your information will be exposed. Data centers, theoretically, data center is like a farm which is closed, but they do the backup. Once they do the backup, they're transferring information from point to point. This is extremely sensitive spot. 5G network and critical infrastructure, obviously. Thank you very much.